The topic of a software bill of materials is super exciting to a lot of people when they start getting into these supply chain topics. And it's certainly one of the most interesting topics that we cover in Sec 547, defending product supply chains. I want to get really deep into the topic of data quality as it relates to SBOMs. We're going to talk a little bit about why quality is so important and what the problems that we see with data quality with SBOMs is. We're going to talk a little bit about what the general expectation of what should go into an SBOM and what are some other things that we should look at from a data quality standpoint, and how do we accomplish some of these objectives. All right. So first off, what is an SBOM? At its core, a software bill of materials. It's just a list of ingredients. It's a list. It's an inventory of your software, the components, the dependencies, the relationships of those dependencies. We get some information about the name and version. We're going to get into some of those elements here in just a moment. But at its core, it's just about what's in your software. Okay. So here's an example software bill of materials. You can see over on the left-hand side of your screen. It's a big old JSON document. You're not expected as a human to be consuming this document. SBOMs are meant to be machine readable documents, but it's important that in order for a machine to read it, that we have some consistency in how we structure this data. The data has to be clean to a certain point because a computer isn't going to understand the ambiguities that you or I as humans can understand when we look at something, and we can pull in context and we can understand if something makes sense or not. But we've got some basic metadata about the document itself. And when we kind of think about, when you think about SBOM data, we think about it in terms of the document that is describing this, that describes the SBOM itself, right? Who created it? When was it created? What tools were used to create it? All that information about the document itself, right? And the document has a timestamp. And then what is it actually describing? It's describing components, right? It's describing maybe a primary component, a piece of software, a framework, a library, and then all the other things that go into it. We can describe other information like what tools were used to create the SBOM. And we can go very, very deep in the amount of data that we can capture in this. We're going to talk a little bit about that as we go through this. What we're showing you right here is just an example of a Cyclone DX formatted SBOM version 1.5, which is one of the more recent versions of the Cyclone DX standard. Okay. But when we're looking at an SBOM, we have this concept of a garbage in, garbage out problem. And this is really no different than any other data-driven process that we utilize inside of cybersecurity. If you are doing vulnerability management and you don't have good asset data, then you're going to be at a disadvantage when you go reach out to your operations teams and try to tell them, hey, we need to get a patch installed on this server. If they come back and say, hey, we installed that patch last Tuesday, what are you talking about? You have an opportunity for some political and chaotic damage inside your organization. That bad data is going to create a problem for you. SBOMs are no different, but it's even more important when we talk about SBOMs, and here's why. Because the SBOM itself, and this is one of the things that people will push back on like the utility of SBOMs. People will say they don't have any useful information in them. They do have very useful information in them, but they don't have risk data in them. The only way that we understand the risks that are associated with our software is by taking these discrete data elements inside the SBOM and doing these external lookups. We'll do a lookup with a vulnerability database like the NVD or the OSV. We'll look at package managers and get information about dependencies and other package-related information about our components. We'll look up malware repos. We'll look up, you may have your own asset inventories that you're looking to correlate the state in the SBOM with. The reality is these are simple strings, right? If I have a simple string and if there's one character off and I'm looking for that string somewhere else, and one character is off, I may not get the result I'm looking for, right? And we wind up, we're missing information, We have incorrect information. Maybe you've got the same component that's recorded multiple times. Is it really in my software multiple times? Or is that erroneous, right? And we start to get in this situation where we have to make a lot of assumptions about the data. Example, we use OpenSSL a lot as an example for like getting software names wrong. Is it OpenSSL? Is it underscore? Is there a space in the middle? Is it OpenSSL project? Is it something else, right? All these strings we see here on the screen may all describe the same piece of software. But if I have recorded that string incorrectly and I'm looking for it in an external data source, I may miss something, right? And so it's important that we get this correct, right? All right. So one of the ways that we look at kind of what makes up a quality SBOM is using what's referred to as the SBOM minimum elements, or the 7 minimum elements. This is a set of criteria, 7 initial fields that were codified by the NTIA as part of Executive Order 14028, which is what a lot of us know is kind of like a lot of the impetus behind current movements of software bill of materials. And as part of that NTIA effort, they identified 7 fields. These 7 fields, some people refer to it as this makes a compliant SBOM. It's not really a compliant standard, but people refer to it that way, an NTIA compliant SBOM, okay? So it's got to have the supplier name. Who made the thing, right? The thing that we're describing, the software that we're describing, or if we're getting into using an SBOM or a bomb to describe hardware or other things, who made that thing? Who made the hardware, the device, the software, the framework, the library, the service, whatever it is we're describing, okay? What is its name? How do we call it? We want to have a way to reference it. We need to know what it is that we're describing. What version? Is it version 1.1, 1.2, 1.2.1? An understanding of version strings and what versions mean. Is it more recent? Is it previous? And understanding the very different version formats we may wind up with in an SBOM is super, super important. We want to know what version that we're describing here. What other unique identifiers, the CPE, a Perl, some other kind of unique identifier. We're going to talk a little bit more about some of these things here in a moment. But we have to have some kind of unique identifier to do this lookup. And these unique identifiers, largely when we talk about our data quality problems, this is one of our most critical elements. I need to have some sort of reference identifier to look up this information and correlate this data. My dependency relationships are super important. This is something I see missing in a lot of SBOMs that are produced today. We've got components, we know who made it, what the version is, and all this great information, but we don't know how components are related to each other sometimes. And some of the less mature SBOM tools kind of create this problem where, okay, I understand what's in it, but I don't know what this all means. I've got a list of 10 components. Maybe it's only top level. I don't know what the dependencies are. I don't know what the transitive dependencies or the dependency of a dependency are. And I may not know, like if I have OpenSSL in my project, it may show up 3 times, and that may be legitimate. But unless I understand the relationships, I may not know that there are component trees throughout my project, and there are multiple component trees throughout my project, multiple nested dependencies that OpenSSL may legitimately show up in multiple places. Who created this document? Who created this SBOM document? Where did it come from? And when was it created, right? And so this is important for us to kind of map this back to who is authoritative to create this. Did the vendor create this? Did the third party create this? And there's nothing wrong with third parties creating this, but we want to get some accountability as far as who created, when it was created. Does it make sense that the SBOM was created in a time frame that makes sense for the version? If we're looking at multiple SBOM documents for the same version, we may want to kind of compare timestamps and see which one is correct. But these are the NTIA minimum elements. Okay. Now, as part of these efforts in industries, we've kind of gone out across the globe, and this is no longer just a US centric activity. So BSI, the German Federal Security Group, put out this TR-03183 document to part two. There's several documents in this series. Part two is around SBOM guidance, right? The version one of this document, which we're going to look at right here, version two just came out like a week or two ago. We have not pulled that into this yet. Biggest distinction there in version two was they kind of split out the concepts of SBOM fields and component fields, but a lot of this remains the same. But in that document, they identified these are the fields that they want to see in a software bill of materials. Now, a lot of this is the same as what we saw in the NTIA minimum elements. They call things a little bit different. A component creator instead of supplier name, component name, it's the same. Component version, same as version of component, unique identifiers, dependencies on other components, creator of the SBOM timestamp. All that stuff is the same, right? Very standard set of fields that we should be expecting to see in the software bill of materials. But the BSI document took things further, right? They said, we also want information about the license. And in the new version, there are several different fields that relate back to license that are part of this. Software license is obviously very, very important to the German government. Hash value of the executable component. We're starting to see hash values of the executable component, of the source code of the component. And one thing that's really interesting here when we start talking about hashing, like we've had hashing in the standards for a while. I myself, when I proposed feedback to NTIA in the original 7 elements, I had asked for hashes to be included in those minimum elements. They were not included at the time. The reality is, even though a hash is deterministic and conclusive, you take an input, you run it through a hashing algorithm, and you're going to get this output, right? There is some ambiguity in how we generate hashes. What are we hashing? How are we hashing it? Are there any kind of specific flags we're using in our hashing algorithm? And even though we have a lot of hashing that is occurring, many of the package managers are doing this. We get commit hashes. We get all kinds of ways we're creating hashes. It's not always clear how those hashes were created. So when we want to create a hash of something and do a comparison and it doesn't match, like the first question I always ask myself, did it not match because it's different, or did it not match because I didn't generate the hash the same way that they did, right? So it's great that we're seeing that in here. It's great that they're giving us some specificity on what exactly is being hashed, right? We get some URI information, like some location information. Where do I get this SBOM from? Where does the source code come from? Where does the executable form of the component come from? So great, we're getting some lookups. We're getting some other references, some other external references, canonical references that we can look at and say, hey, it's not just these fields. If I have question, if the field doesn't match and I want to go look it up and kind of validate what I'm seeing, now I'm going to get some of those references in here as well. Okay, that's fantastic stuff. All right. So let's talk a little bit about some other quality criteria that we might want to see in this process. So the software component verification standard, which is a project from OWASP, from the same fine folks behind CycloneDX, Dependency Track, Perl or Package URL, and a bunch of other great supply chain and software assurance related projects at OWASP, have come up with this BOM maturity model that describes essentially a taxonomy for what should go into an SBOM, right? Like what kind of, we kind of break it up into kind of like 4 separate, we call kingdoms, right? Kingdoms and domains is kind of the way that they describe their taxonomy, right? The largest of these is the resource kingdom. There are 170 criteria. Now, most of those are around software, but because it's the BOM maturity model, not the SBOM maturity model, and because CycloneDX also supports devices and services describing APIs and data flows and things like that for SaaS models, all of that is kind of encapsulated in this maturity model. We get a lot of really great understanding when we get into like how deep should we go? How broad should we go in SBOM, which is something that we really haven't traditionally gotten from other guidance. But again, a whole bunch of criteria. You can go take a look at the BOM maturity model and see everything that's in there. We are expanding on this now. pedigree and provenance and formulation. These are use cases that have been supported in Cyclone DX for some time, but now we have a maturity model that's describing how we should describe pedigree, the lineage of the software, the provenance, where did it come from? How do we gain assurance that we know where it came from, and it came from an origin that we can authenticate and validate, and use cryptography to validate, so we have high assurance that we know where we got it from. Our software is assured, and formulation, how are things created, right? So we get a lot of really great information that gives us, and this is all data enrichment in the SBOM. This is not about those 7 minimum elements and making sure that they're perfect, but they're saying, how far do we take this? How deep do we take this? How broad do we take this? How complete do we need this? And the other thing that they did that was really great is they created this concept of profiles. And so what I can do is I can take kind of subsets of use cases. Now they put the initial NTIA profile out there, 7 minimum elements. This is what I'm looking at. This is how I'm going to slice this SBOM and say, I have a quality SBOM because my requirements are for the NTIA set of fields. I apply the NTIA profile, I validate against the NTIA profile, and I have a good SBOM. But maybe there's some other criteria I want. Maybe I have a foci scenario here where provenance is super important. The origins of my software is super important to me. We're seeing a lot of movements, especially at the U.S. federal government, around software provenance. We don't want to have problems with either certain banned origins, whether it's a country or whether it's a specific organization or company that we don't trust, and we don't want to pull those into critical infrastructure and defense settings. So maybe I apply my foci profile. I will pull in all those provenance criteria. And maybe I care, maybe at that point, in that particular use case, I care less about the NTIA criteria. I'm really focused on provenance, since that's important to me. We have threat modeling profiles, AppSec profiles, a bunch of other profiles that can be created out there. Highly recommend go check out the software component verification standard, not only for the BOM maturity model, but for the great framework that they provide. Provides a lot of value just within our supply chain assurance activities, everything from describing what should be part of our build process, to our inventory, to our SBOM, provenance, and a bunch of other really great criteria. Okay. All right. Then we've got this whole concept of quality checking. So how do we know whether we got a good quality SBOM or not? So there's a bunch of open source quality checking tools that have emerged out there. The one that I in the early days I would hear a lot about was the NTIA conformance checker, which is an SPDX being one of the 2 primary software bill of materials formats. Now, the NTIA conformance checker, for what it does a good job, right? It's for SPDX SBOMs, and it checks for the NTIA minimum elements. We just want to make sure that we had all the elements. It is actively developed, maintained by the SPDX community. Well, I just checked a few days ago. The last commit was just a few weeks ago, right? So actively developed, great for what it does. But again, it's just for SPDX. SBOM QS, which we're going to look at a couple of examples here in a moment, is another tool, open source utility from the fine folks at Interlink. They also have some commercial products. They also have like an SBOM benchmark website where you can upload your SBOMs, and they will run through the same tool, Quality Checker, and you can upload your results, and they do some comparisons. You can kind of see, hey, this tool creates beautiful SBOMs. This tool maybe less so, right? Or maybe we've got some opportunities for improvement. But you can see, like, most of the criteria that we're looking at least on this slide, SBOM QS, in my opinion, is one of the more comprehensive tools here. Now, we can argue how effective these checks are, and does this have all the checks that we need? But SBOM QS is an excellent tool. It's also actively maintained. And then we have SBOM Benchmark, which also supports both formats by the folks at eBay. It does also do specification compliance and looks for the base package information as well. It's not as fixated on things like NTI minimum elements and so on and so forth. But I want to kind of go through some of the criteria very quickly on what SBOM QS captures. I think it's super interesting. So Obviously, it's important that when we say spec compliance, we're really talking about, is this a valid Cyclone DX? Is this a valid SPDX? Does it meet the schema requirements for the JSON or XML document that we're looking at? NTI minimum elements, it's those 7 elements. SBOM QS has actually captured also the BSI minimum elements. They have at some point in time called it CRA compliance or something else. It's not really, doesn't really have anything to do with CRA, but it is those BSI minimum elements that we just looked at just a few moments ago. The same kind of information about the package itself, the checksums, the hashes about that package. But we also get into some other information about how verifiable is this metadata. And one thing that I think is really interesting, really important to hone in on for folks, is an SBOM document has a license. It is a licensable piece of content. And one of the things I get pushback on is I think if I create and share an SBOM, I have to share it with the world. No, that's not true. You can decide how the SBOM document itself can be shared, who can be shared with, and that is shareable license flag is one of the things that SBOM QS looks for. Okay, so now let's look at here's output of a couple of these different tools. The SBOM benchmark and the SBOM QS tool, and the eBay tool and the interlink tool. And we're looking at a very old version of the Django REST framework. The Django REST framework is just a part of the Django framework that's used to create REST APIs, right? It's a library that's used as part of that. It's a very simple SBOM for us to look at, depending on how you count the components, somewhere between 2 to 4 components inside the software bill of materials. As you can see, over on the left-hand side, up in the upper left, we have the SBOM benchmark output. This is what you get as an output from the SBOM benchmark tool. Spec compliance, okay, I got full points because it meets specification. I've got the package ID, meaning everything either has a PURL or a CPE, a package URL or a common platform enumeration. CPE, again, is what we typically use to look up vulnerabilities in the National Vulnerability Database, and PURL is an identifier, more decentralized identifier with the controlled namespace. It's controlled by the package managers, and so you see a lot of open source package managers using PURL. We've got package versions. We don't have any license information, and we got information about the creation. So it gets an 80, right? 80%, a pretty good score, okay? Then we look at our SBOM quality score, the SBOM QS. Only gets a 5.7 on this particular one. You can see we're looking at a lot more criteria, right? We're breaking out the NTI minimum elements. Well, we notice we don't have supplier information. Component with supplier, 0, big fat goose egg. No information about that. We don't have any information about dependencies in this SBOM. So we're only really hitting 5 of the 7 NTI minimum elements. You can go through and look at some of our quality components. We don't have license information. And there's several checks that are related to licenses. So if I don't have licenses, I'm going to fail every check that is related to licenses because I don't have them at all, right? Got creator information. We have some semantic criteria, right? Do we have checksums? Again, license failures. Do I have my required fields? Is it shareable? Again, like, do I have that license in here that says I can share this SBOM? And some other structural elements, right? Like, can I actually parse this document? Like, can I actually do anything with it, right? And some specification compliance and some other information, right? So a much more comprehensive set of criteria here. Of note, because the SBOM benchmark has not been updated since 2023, it does not support some of the newer formats. So for instance, when the first version of the SBOMs that I was looking at here and trying to do this comparative testing, I had a Cyclone DX 1.5 formatted SBOM. SBOM benchmark could not read it at all. I got 0 results. I had to go look at a Cyclone DX formatted 1.4 document, which it understood. So as these versions expand, you're going to want a quality checking tool that can actually keep up with the specifications that you're using inside your process. Okay. Now let's look at the SBOM quality score for an SBOM, the same software, but now we're looking at SBOM that wasn't created. This previous SBOM was created with the Cyclone DX PY tool, right? Just a Python specific library that's used. That's born up on the core Cyclone DX utilities. Now it's to the CDXGen. CDXGen is quickly becoming one of the more feature-rich, also Cyclone DX ecosystem tool. It supports multiple languages. It has a bunch of amazing capabilities in it. And we get a much different looking SBOM. Now we're up on the 80% or so, right? 57%, 80%, right? We're getting a much better quality score just by using a different SBOM tool. You'll note that in this one, we actually get a primary component. There was no primary component in the other version. We get multiple components. Some of this is just based off of how it's referencing itself. Or actually, Django REST framework is the thing that we are describing, but it also gets listed as a component in here. We're getting license information in this tool, hashes, we're getting component evidence, again, detection techniques, which is really awesome to see, and SBOM lifecycle information. And we even saw that we were able to eliminate a wrong dependency, the coverage dependency that was identified in the other SBOM, which is actually not something that ships with the component, it's just used for testing, okay? All right. So accuracy, depth, how do I know how good this is? Okay, yeah, I met all this criteria, but is it doing what I need it to do? Am I getting the completeness that I'm looking for? We still really don't have a good grasp of that, okay? So how do we figure that out, right? So one of the things we can look at, we can use data enrichment capabilities to make our SBOMs better, right? So on the left-hand side, this is just the user interface for dependency track. We could go through, we could add the author, we could change the version, we could add licenses manually and just regenerate the SBOM within dependency track. Or on the right, you see this kind of example of a pedigree use case from the Cyclone DX website. These are some of these use cases are things that the tools don't support. So if the tool doesn't support it, you may have to roll up your sleeves and do it yourself. For instance, we're capturing pedigree, all the ancestors, the commits and the patches that are related to the pedigree of that software. You probably will not see this in any other SBOM generated tool. Most SBOM tools are not capturing this information, but the standard allows for this information. So you may have to do some of this manually, unfortunately. Yeah. All right. So the other piece I wanted to kind of explore is this whole concept of evidence. So with Cyclone DX, we've added this concept of looking at methods, like how did I identify this component? It's just this to string comparison. Did I instrument the code? Did I use some sort of dynamic analysis? Did I use some sort of cryptographic mechanism, some other kind of fingerprint? Was I doing hash lookups? We get all this confidence information, and confidence in Cyclone DX is 0 or 1. It's either I have confidence or I don't. It's not like a really kind of granular scale, but we have the ability to start to say, how truthy is this, right? We can look at things like the call stack. And with CDXGen using events, we start to get things like call stack evidence. We go file evidence. So it's not just the SBOM itself, but we can generate a report that says, this is why I know that this is correct, because I've got evidence that tells me that it's correct, okay? Okay, so where do we go from here? This is where this is the kind of stuff that we need to start capturing. There's a lot of problems that we need to fix in the SBOM space. The naming problem is probably one of the most important things we have to solve for. I'm a co-leader of an OWASP project called the SBOM Forum, along with Tom Ulrich and some other folks. And this is one of the main things we're working on. How do we get Perl into proprietary software? How do we use this SWID naming standard and use it with Perl and kind of solve, we kind of address this from open source, but how do we fix it for proprietary? Again, that's going to help our data quality. How do we handle software lifecycle? So the Common Lifecycle Enumeration Project is another OWASP project. Is going down this road. Data exchanges, the Transparency Exchange API and DBOM and some of these other mechanisms. The better we get better data exchange and better testing of this, right? We haven't seen a lot of recent interoperability testing outside of just random people that are doing tests and then submitting tickets. We need more plug fests. We need more community involvement. CISA does a great job of evangelizing and getting people together. We need more working plug fests We're actually doing interoperability testing. We've got to agree on how are we going to measure quality. Again, SBOM benchmark, SBOM QS, they're looking at different things. How do we know what's good and what's not? And getting better governance in our process, right? So Cyclone DX has moved to adopting or being adopted by ECMA TC54. Going through that standards process. SPDX has been an ISO standard for a while, but these governance models, they help us out a lot as well. Okay. All right, so I hope you gathered how important that SBOM data quality is and some techniques we can use to go from there. We also cover this deeply in Sec 547. We've got some upcoming dates in November, January, and April. Sign up for on demand. We'd love to have you in an upcoming run of the course. As always, thanks for tuning in and listening to me talk to you about SBOM data quality. It's been great. And I will leave you with our closing slide. So get in touch with us. Thanks, and I hope you enjoy the rest of the sessions.